Welcome to GER Home Mathematics and Statistics lessons. In today's video, I'm going to be solving this problem. Find the third term when x over 2 minus 1 in bracket raised to power 8 is expanded in descending powers of x. So let's solve this problem. So I'm going to begin the problem with writing out x over 2 minus 1 raised to power 8. Okay? And I'm going to be using the binomial expansion for doing this. Now you would eventually realize that you can actually get the third term requested without even solving a thing. But let me show you how it is done. So the binomial expansion requires that we do this. So I will start with the first term. I'm going to write x over 2, the first term, and put here plus minus 1, all raised to the power of 8. So that's what I'm going to do, knowing fully well that plus times minus 1 returns minus 1, so I've done nothing wrong. So the next thing I'm going to do is to apply the binomial expansion. So from the binomial expansion, the first term carries the power, the total power 8. So I'm going to write here x over 2, starting with 8 combination 0, okay? The power here, 8 combination 0, and in bracket, I'm going to have x over 2 all raised to the power of 8, okay? And then minus 1 raised to the power of 0. So this will be the first term. Now, according to the binomial expansion, every term must be combinatorial in nature. So you have 8 combination 0 starting the expansion. The next term that follows, which is the second term, take note, will carry 8 combination 1. So as we move from term to term, from left to right in the binomial expansion, take note that the power of the first term keeps dropping while the power of the second term keeps increasing, and at every point in time the total power 8 plus 0 will return 8. The total power must return the total, the sum of the two powers here must return the total power. So this is 8 combination 1, and the next will be x over 2 all raised to the power of 7. This time around 8 drops by 1, and because 8 drops by 1, the second term minus 1 increases by 1, so this will become 1 from 0. And the third term, which is where we are going to stop in the expansion, actually gives this 8 combination 2. Note I increase from 0 to 1 and now to 2. So 8 combination 2, x over 2 all raised to the power of, you guessed right, this will drop from 7 to 6, and this will give us minus 1 raised to the power of 2. So the expansion goes on. Now, remember the question demands that we find the third term when x over 2 minus 1 is raised to the power of 8. Raised to the power of 8 is expanded in descending order, meaning that this is what the question demands. Okay? Find the third term when this is expanded in descending powers of x. So the third term will be this. Now, bringing out that third term, what would we have? Now, all you would end up seeing for that third term will be this. So let's bring out the third term, which is 8 combination 2. 8 combination 2 x over 2 all raised to the power of 6 in bracket minus 1 squared is the third term. And that, when it simplifies, gives us 8 combination 2 is 8 factorial all over 8 minus 2 factorial, 2 factorial. And x over 2 raised to the power 6 gives you x raised to the power 6 all over 2 raised to the power 6. And minus 1 all squared returns 1. Okay? Now, 8 factorial over 6 factorial, 8 minus 2, 2 factorial is what you have here. And this multiplies x raised to the power 6 all over 2 raised to the power 6, which is 64 times 1 returns the same thing. Okay? So I will do this finally 8 factorial is 8 times 7 times 6 factorial all over 6 factorial, and this would cancel this, times 2 factorial, which is 2 times x raised to the power 6 all over 64. So what do I do? 8 can of course cancel 64, leaving me with 8. So I'll end up having my result as 7 times x raised to the power 6 divided by 2 times 8, which is 16. So this will be the third term of this expansion in descending powers of x. Thank you very much for watching this video. Do like, share and subscribe to the channel for more updates and more info on the channel. So thank you very much. Until next time.